So we continue the stochastic processes. We talked about all this stuff, steps in formulating we talked about what a sigma algebra is, right? And then these are examples. So we want to look at generator of a sigma algebra. Okay, so it happens that there are some elements that can actually generate sigma algebras. Okay, right. So for any set C, which is a subset of the omega, okay, so there is that subset of omega, right, which we define by that the smallest sigma algebra, which contains C. So it happens that you have your omega, right, and then now omega, as you know, is a certain set, right? So here 1, 2, 3, these are the elements in omega. Okay, so these are the elements in omega, but there is a certain subset of this omega, and we are calling that subset C. Alright, so we can see that the C is 2, 3. Okay, so let's take that. So we are saying that this C, okay, this C, we can define this C a sigma algebra which is generated by this subset. Okay, remember that we say that sigma algebras are collections of what? Subsets. Okay, so say a sigma algebra is when you have a set, right, that contains subsets. Okay, subsets. So that's basically what a sigma algebra is. So remember that there is this omega. So look at this example. This is the omega 1, 2, 3, and then we are looking for that C which can generate a sigma algebra. So this is the C. Okay, so this C, to generate a sigma algebra, we have to remember the conditions. So the first conditions of a sigma algebra, we say that the empty sets should be there. So the sigma algebra generated by this will have the empty sets, and then the set should have the main sets there. Alright, so the omega 2 will be there. Now the set which is generating the sigma algebra must be there. Alright, so we should have 2 and 3 also there. Right, and then the complement of this, remember per the rules, the complement must also be in the set. So the complement of this is 1. Okay, 1, the set containing 1 must also be in the set. And then you look at the intersection. When you intersect this and that, you get empty sets, so that is okay. When you union this and that, you get this set, that is okay. Alright, when you intersect this and that, you get empty sets, that is okay. So what else? What's the complement of 1? Complement of 1 is 2 and 3. Okay, alright, so when you look at this, it's complete. Okay, the complement and the unions, everything is inside, so you close this. So we call this set a sigma algebra. Alright, and this sigma algebra is generated by what? C. So we denote that by saying that the sigma algebra, and then we put in our C to show that that sigma algebra is generated by what? C. Okay, so that's the meaning of a sigma algebra generated by C. Okay, so you see that the smallest sigma algebra which contains C. I remember that when we did that, you saw that C was inside that sigma algebra. Alright, so this is a typical example. Okay, so this is a sigma algebra generated by 1. Okay, so the sigma algebra generated by 1 will have the empty set, the set itself, the complement of 1, and then the unions and everything. So it happens that C1 is a generator of a sigma algebra. Alright. So the C is a collection of subset of that, the minimal sigma algebra generated by C, generated by that. Alright. So remember that your C, which is generating the sigma algebra, must be found in that sigma algebra generated by C. Right. So example for this, the set C, which is this element, generate the sigma algebra which contains all set of all 8 subset of that. Okay, so if you are looking at this sigma algebra which is generating this set which is generating a sigma algebra subset, I mean, remember this is a subset coming from that. It's a collection of subset which is coming from this guy. Okay, all right, so you should be able to, if you pick 1 and 2, you should be able to generate the sigma algebra. 2 and 3 to generate a sigma algebra. Even if you combine them, 1, 2, and then 2 and 3, you combine them. So remember that the sigma algebra must first contain the empty set, right? The set itself, which is omega, and must contain the C, right? So it will contain the C. And remember, C has 1, 2, and then also has 2, 3. Alright, so you have to look at the complement of that complement. So complement of this is a 1. Alright, complement of this is a 3. Alright, so when you do the intersection, you do the union intersection. So when I union this, I'll get this. When I union this, I'll get that. When I union this one, this and this, I'll get this. When I find the intersection of this and that, I'll get a 2. This and that, here I'll get a 3. When I find the intersection of this and that, I'll get a 2. So 2 should be part. 2 should be here. Right, and then close. So these will be the sigma algebra generated by C. Okay, so sigma algebra generated by C.